Okay, EG5. Particle of mass 0.5 kilos is moving under the action of a single force F newtons. At time t seconds, the position vector of p r meters is given by that expression. So I can see mass, I can see force, so I'm thinking Newton's second law. I've got a position vector in terms of t, so I know that I can get acceleration from that. So my thought process is, at some point I'm going to be working with Newton's second law here. So the first thing they want us to do is find the value of t when p is moving parallel to the vector I. So if it's talking about motion, then we need to find the velocity vector. So let's do that first and then figure out how we can use it. So we're given r is 3t squared upon 2 minus t cubed upon 3I plus 2t squared minus 8tj. And in order to go from position to velocity, I am going to differentiate that with respect to time. Okay, so when I differentiate that, I'm going to get 6 over 2, which is 3t, and when I differentiate that, I'm going to get t squared, and then on this part I'll get 4t and minus 8. Haven't got to worry about any constants because I'm differentiating. Now I want to know when the motion will be parallel to the vector I. So if it's moving, so that's basically saying it's moving in a horizontal direction. It's got no vertical component to the speed, to the velocity pulling it upwards at all. So that will be moving parallel to vector I when the j component is 0. So when the j component, the velocity equals 0. If it was asking you to work out the time it's moving parallel to the j, then that means it would be moving vertically. It would have no horizontal component, so the I component would equal 0. So here, the j component, the 4t minus 8, I'm now going to put equal to 0. So this occurs when 4t minus 8 equals 0, i.e. when t equals 2 seconds. So at the instant where t is 2 seconds, then the j component will be 0, so the velocity is only moving in the I direction. So that's part A. And then part B, the magnitude of F when t equals 3.5. So for F, I need to use Newton's second law. F equals ma, and the vectors in this case, so I'm underlining the two vector parts. And the acceleration is going to be dv dt, which means now I'm differentiating these, and I get 3 minus 2t and 4. So that is the acceleration vector when t is 3.5. A will be 3 minus 7 is minus 4. Now F equals the mass, which is 0.5, times minus 4, 4. So as a vector, the force is minus 2, 2. Question's asking for the magnitude of the force. So to find the magnitude, I use Pythag. Which is going to be root 8 or 2 root 2 newtons. So sometimes you need to think carefully when it's talking about a motion, how that would work. So the most common ones would be parallel to the I component, which is what we've just done, and that one would equal 0. Parallel to the J component, which would be when there's no horizontal, so that would equal 0. Or if it was moving at 45 degrees to the horizontal axis, then that would equal that. Okay, so that's EG5.